a co-founder, oh, there we go with the audio, an architect at Hortonworks. I've been working on Hadoop for a long time, and so one of the roles I had was I was the architect when we added security into Hadoop. So I've been playing with and working on Hadoop security for a long time. So the important thing when it comes to security is to understand what exactly you're protecting against, right? What are the threats that are coming to attack your data? So rather than focus on the technology, you want to think about what threats are important to you and what are your technology solutions to address those threats. You want to think about how the bad guys are going to get your data, right? Are you worried about insiders? Are you worried about outsiders? Who are you trying to protect against? How are they going to get in? And finally, just as a general practice, you want to go through and minimize your attack surfaces, right? If you give someone a wide open canvas and you think everything's secure, but you've given them a lot of places to attack, you're not nearly as well off as if you've given them a very small portal to attack. And so you want to think about what your attack surfaces are and how to minimize them. So this is the overall security picture that you need to think about. When I talk to companies about their security, the first thing they want to know is, okay, what are all the ports that Hadoop opens and what protocol is going over each one? I'm like, okay, first, you need a firewall around your cluster. If you don't have a firewall, you're giving the bad guys a huge advantage because you really want to lock the data in so that only the machines inside the cluster have access to everything, and you can control exactly what the people outside the cluster have access to. Now, traditionally, that meant that you had a gateway node that your users SSH'd into. So they had HTTP connections to the masters so that they could look at how their jobs are doing or whether the file system was full. But typically, they would go and SSH into the gateway machine, do their authentication there, and do all their work from the gateway. Recently, well, relatively recently, we've added a project called Apache Knox. Apache Knox provides an HTTP gateway that lets you replace those SSH gateways and lets everyone use REST interfaces to access the services inside the cluster. So you really have the two options. You can do it either way, and it really depends on what your users are more comfortable with and what they need. You can see that inside, of course, there's a lot of details. You want the masters, the name node, and the resource manager to be separated off because those slaves have user code running on them. So you really, really don't want to have them have as much access to the central services as the masters. And the masters, you shouldn't let the users log into at all. Actually, in general, you don't want the users to be able to SSH into any of the slaves or the gateways, or sorry, only the gateways, and not the slaves or the masters. So what are the places that we're worried about, right? So the first is if they can get physical access to the machines. So we'll talk about that one. The next one is if they're outside that firewall. If they're outside that firewall, then you've got a lot more options in terms of what you can protect against. The next is if they get onto the gateway machines, then they've got better access, but you still have a lot of options. And then if they get onto the slave machines or the master machines, you've got correspondingly fewer options. You also need to think about what level of access they have on those machines. If they have root, you're pretty much toast as far as that machine is concerned. There are security vendors that like to say, oh, we protect against root. Don't believe them. The root has access to memory, so if you've got a secret in memory, root has access to it. It's not that hard to write a program that paws through memory looking for those secrets. You saw this with the Heartbleed bug, right? The Heartbleed bug gave you a random chunk of memory, not even letting you pick where to go. and yet it was leaking secrets all over, given enough trials. If root can look into procmem exactly, there's nothing you're going to do about it. So lesson number one is don't give your users root, and cut down the number of people who have access to root to an absolute minimum, because root's going to be able to get in. Now, the next level is a Hadoop administrator. They have been authorized to do things at the Hadoop level, but they don't have root. So that they're trusted to access any file in HDFS, to kill any job. So they're the people who are running the cluster, but they don't necessarily have root. And finally, there's the users. They're the people who have normal access and they get restricted by HDFS permissions. The first case that you need to think about is just accidental damage. This came up when we started with Hadoop. There was literally no permissions on it at all. You had no protection at all. And a class up at UW was being taught and to teach the students how to use Hadoop. One of the students accidentally deleted not only their home directory, but everyone's home directory. Gone. And one of the Hadoop sysadmins said, people do stupid stuff all the time. Hadoop lets people do stupid stuff at scale. And it's really true. This person just made a mistake, right? They hit one level too high. They were trying to clean something up, and instead of cleaning up their directory, they deleted everyone's directory. And unfortunately, Hadoop is very, very efficient. It can delete hundreds of terabytes in seconds. So that's kind of unfortunate. And so we added permissions. Permissions are good. And I highly recommend that you have permissions turned on, even if you don't turn on any of the rest of security, because they prevent accidents. We also had a user who had a Python script that ran under MapReduce, and they knew they spawned a bunch of children. And so they were trying to be very helpful. When their task was done, they decided to clean up. They did kill all -9 Java. Now at that point, all the MapReduce tasks were still running as MapRed. So what that did, of course, was killed every process that MapRed was running that was running Java. That included all the task trackers. So what we saw was all of a sudden half the cluster disappeared. This was not good. So we wrote the Linux task controller, which later became the Linux container executor. And that is a little piece of C++ code that lets you run your MapReduce or Yarn tasks as the user themselves. That does mean you need the users provisioned on the cluster, but that means that they can't accidentally step on each other, right? You can protect data from each other with local files. The users can't kill each other's processes. This is a good thing. One of the amusing pieces of history is you can turn this on even without any of the Kerberos security. So you can actually run this way without any of the other security turned on, and that was precisely because we needed to get this isolation even more than we needed security. Okay, now if the user is outside of your cluster, what do you need to do to protect yourself? Fortunately, each of the services provides a service level authorization. This is so that you can define the list of users that are allowed to access that service. Because especially if you're missing that firewall, then anyone in your network can connect into the name node and do an LS. They may not see very much because there may not be very much that's publicly visible, but you still don't want them to get in, right? It's about minimizing your access surfaces. And so you really want to define the service level authorization so that you can control exactly who's allowed to access your cluster in which way. There's a new project called Apache Ranger, and one of the cool features that they let you do is they give you a single pane of glass where you use a web UI to define all the service level authorizations for all the main projects. So you don't have to figure out, okay, how do I tell HDFS who the users are? How do I tell Yarn who the users are? How do I tell HBase who the users are? You can all do it using Ranger directly. you definitely still need a firewall, and this whole thing controls the attack surface. All right, so if you're blocking people outside, now you want to start thinking about eavesdropping on the network. Again, root can watch traffic going across the network. This is part of why root's a problem on your cluster. And so if you have a firewall, then you only need to worry about root access inside that firewall. If you don't have a firewall, then you need to worry about root outside the firewall. And that's much harder, of course. Because at least at most companies, the user can plug an arbitrary machine in at their desk, and they'll have root on it. If it's in the data center, you can trust it much more that the root is controlled and they won't have access. So keep root outside the cluster and keep that firewall in place, and you'll be much better off. Now, because the HTTP connections go outside the cluster, you're going to want to enable SSL. That definitely helps your security, because then root outside the cluster can't eavesdrop on the people connecting in and steal their credentials. The rest of the stuff is actually stuff that stays inside the cluster. And so I actually recommend not turning those on. The shuffle is the MapReduce or yarn shuffle, where the data is transferring between tasks. That one, all of these, of course, cost some performance. And because they're only protecting against root inside the cluster, most companies don't need it. So evaluate your concerns and decide whether you need encryption here. The data transfer is the protocol for HDFS, and you can turn encryption on there. And finally, there's the RPC encryption, and you can turn that on. Although, to be blunt about it, the RPC encryption is done with MD5, and MD5 is not the strongest encryption that you could ask for. Okay, so the next level, the user has access to your cluster, but you want to protect against private data. There's a group at Yahoo that's called the Paranoids. You can figure out exactly what they do, is they try to figure out attacks. We were using Hadoop, everything was fine. We didn't have strong authentication, and but people were using it and getting along fine. The Paranoids figured out that you could do Hadoop-U and then put a username, and then you became that user. The users loved it, but the Paranoids were not so excited by that feature. Or rather, they were very excited, and they said that needs to go away. So then we did the work to secure Hadoop, and we added Kerberos. Kerberos is a strong two-way authentication, so that you're both sure that the user is who they say they are, and you're sure that the server is who they say they are. So that is important, so that, for example, someone can't start up a fake data node in the cluster because it'll try to connect to the name node, and the name node will say, hey, you're not a real data node, go away. So this is important, and furthermore, when they're talking to a yarn, they're sure that it's actually a yarn server, not someone pretending to be yarn. And they can be sure that they aren't giving their credentials to someone who's not supposed to get them. So HDFS permissions are, of course, the biggest value here. And recently we added ACLs. So ACLs let you get more fine-grained control over who has access to a particular directory or subdirectory tree. So one of the pieces I recommend is that you make a directory for each group and put all the stuff underneath that for the group, because that lets you set the permissions at that top level and lock it down there. One of the pieces that also comes up often is that users want to, or rather system administrators, want to define specialized roles. They want to define special capabilities. And Hadoop actually has a plugin that lets you do this. That's the user-to-group mapping. So if you have a plugin that can talk to your authentication server and it can say, oh, that user's in roles 1, 2, and 3, and then the user to group mapping could add that on to their natural groups, and then you can use those groups in your HDFS permissions. And finally, you really need to minimize the number of global spaces. Global spaces are very likely to leak information if you aren't careful. All right, so physical access. How many of you think that if a computer has all of its USB ports soldered over and no ports, that it's completely secure if it's got an encrypted file system on it? Good, because it's not. You have no hope of controlling it if they've got a physical access. To take it to the extreme, even with not being able to boot up from remote ports, if someone did a study where they took a computer's RAM and froze it before they pulled it out of the computer, they had 30 minutes after pulling it out of the computer to still read the data that was in that RAM. So if they've got physical access, they can get your private keys that are in memory. So obviously, you need to keep people out of your data centers. Now, another use case that does come up is people are worried about, okay, well, what if they can get the drives after they've been retired? Most large companies will destroy the drives completely. I was really excited when I was at Yahoo and they said they were selling old laptops. I was like, oh, great, I can get a cheap old laptop. Then I found out, oh, no, they destroy the hard drives completely. So you get it without a hard drive. And you have to supply one. And then it wasn't nearly as attractive. So if your company destroys their hard drives before they leave the data center, then you're in good shape. Otherwise, an approach to use is the file system encryption. Because while the system's running, that stuff's visible. It doesn't protect against anything except losing the drive. But if you're worried about someone stealing a drive out of your data center, then you can use the raw file system encryption. And then all of your data will be encrypted down on the disk. But while the computer's running, the keys are in memory, so it's available to anyone on the system at that point. OK, now, if the user or the attacker has access to a Hadoop admin, they have a lock. They can get through all the HDFS permissions. They can see everything. And so you can actually do a couple of different things. But one of the new pieces is the HDFS encryption zones. It basically encrypts a whole subtree with encryption. Each file gets a unique key so that as you read it, you only find out the key for that file. The user never gets the actual key for the master zone. But the client actually decrypts the data. That means that the user still has high throughput because they're decrypting the data themselves rather than pushing all the data through a single service. Hadoop, one of the things it's really good at is streaming a lot of data very fast. So that any solution that requires all the data to go through a single point is going to fail. I've seen Hadoop take down NFS servers, web servers, pretty much anything, because someone did something like reference their home directory, mounted it across a cluster, and that takes down the filer. So you really don't want anything where all the data is going through a single point, and so this avoids that. Now, before we had this capability, what happened was you had to make a separate cluster effectively. You'd want to, if you had something that you had to keep secret from some subset of the Hadoop admins, you'd make a separate cluster where the secret data was and they didn't have access. This is a lot more convenient, although it's still pretty alpha. So HDFS has an encryption zone. The master key is there. Each file gets a random key, and that random key is encrypted with the master key and stored as an HDFS attribute. So HDFS has all the pieces, but it can't actually decrypt the zone. And the Hadoop admin can't get the keys decrypted because they don't have access to the key server. So it talks to a key server, says, hey, decrypt this encryption key, and then that goes back to the user, and then the client decrypts the HDFS file. Okay, so how do you manage these keys? We didn't want to make it so that there was one specific way of defining where to get keys. So we defined a key provider API. It provides general key management. It allows third-party plugins. So if your corporation has a key provider server already, it can plug into that. It lets you name keys, and it supports both key versions and key rolling. So that is for a particular set of use cases. In particular, companies have this requirement that they can only keep personal information for 90 days. After that, they have to destroy it. And so what they can do is write the data with a key and then destroy it after 90 days. And that will keep the data secure, and they don't have to rewrite all the data. The key management server, there's one in Hadoop that's really alpha. I wouldn't actually suggest putting it into production yet, but we're working on strengthening it. Actually, the Ranger guys are making a better one and putting that, and that should get released pretty soon. What does the encryption actually look like? It uses AES, which is the encryption standard at this point. And it uses a variant called CTR because we needed to support seek into your HDFS files. Because if you seek into a file, you want to be able to start from the very point where you seek to, not at the very beginning of the file and have to decrypt all the way through. It doesn't make your files any longer. It doesn't have to pad it out to a complete number of bytes in the encryption block. And it uses an initialization vector. The initialization vector means that it doesn't, if you have a file with all zeros, it doesn't always look the same. It will get a randomized initialization vector, and that set of zeros will look different on every file. Okay, so switching gears a little bit over to Hive. So one of the classic cases that people worried about is that when Facebook designed Hive, they didn't worry about security very much. And so we had this case where the Metastore knew about tables and HDFS had the data for the tables, but the two permissions weren't tied together. And so people could go in, tell the Metastore to delete the table. It would say, OK. And then it would fail when they tried to delete the directories out of HDFS because they didn't have permissions. The fix for that is we created a storage-based authorization module for Hive. And if you configure that, then the table permissions are taken from HDFS. So you need to manually go through and change the owner and group of the directories for your tables in HDFS. But once you do that, then the permissions in Hive will exactly match the permissions in HDFS. So that gives you an actually secure Hive setup because HDFS is secure and Hive is following HDFS. That means that users can't escalate their own privileges. They can't delete things they shouldn't be able to delete. And so this was goodness. The one downside, though, is that they could still read columns, right? If you defined a view that only had some of the columns, it wouldn't act like a normal database. It would say, oh, the view is backed by that set of files, so the user has the same permissions on the view that they do on the underlying file. So if they had permissions on the underlying file, they could see the view. If they didn't have permissions on the underlying file, they couldn't see the view. That didn't make users very happy, so we created SQL standard auth. That basically extended Hive with a full set of the grant permissions. Early versions of Hive, it, again, was very convenient, like the Hadoop U command. you could grant yourself any permissions you didn't have right now. So you could say, oh, I can't access this database, fine, I'll grant myself permissions on that database. Very convenient, but not secure. With standard SQL auth, now grant is a permission, so you can only grant yourself permissions you're allowed to grant, and you can go through and configure which tables people have access to. On the side, of course, you still need to protect HDFS, but to use this well, typically users configure all the normal users to go through Hive Server 2, which if they're using JDBC is pretty easy because they would always go through Hive Server 2. And as long as you do that, then you only need to give HDFS permission to the tables to Hive itself. They don't actually need to, the users don't need individual permissions to the table. So that is definitely one approach. However, one of the problems with Hive Server 2 is that you don't want to enable user code to run in there because the user is running as Hive Server 2. Then they have access to all the HDFS files that Hive Server 2 has. And so to protect against that, we're working on column encryption in ORC. And what that will do is it'll use strong encryption on the entire column. So it's format specific. It will encrypt the data altogether, and we're working on that in Hive 4.2.7. So the strong part of that is that you can use different keys for different columns. And because Hive knows where those columns are, it can encrypt just those columns with each key. So for example, back to the example of having PII data in your files, you could put the PII columns encrypted by the PII key, and only people who had access to those PII keys could see those columns at all. Everyone else would just get nulls for those values. And so that really lets you hit a whole set of use cases that you can't currently hit. Now, if you combine that with the key rolling, now a company that needs to only keep the PII data for 90 days can just destroy the key, and they lose access to those columns after the 90 days. Part of the reason this will work is, and we're working on the column encryption now, is that Hive is a columnar format and separates the columns into individual byte ranges. And so each of those blue ranges is a different column, and it can encrypt just the bytes in those columns. Now, of course, it also has to encrypt the indexes, which are the green parts. So each column will get encrypted separately, and they can each have a different key if you want it that way. Okay, now there's an additional option that isn't baked into any of the formats, but instead is a UDF. There are a couple of third-party companies that sell these, and they basically encrypt each value. Now, this isn't as complete as what you get with column encryption, right? Value encryption, you can tell the difference between a null value and a not null value, because the null value is going to be really small and the not null value is going to be huge. And depending on the details here, most of the time you can also join on these. So if you value encrypt, then you can still do joins on those columns, which depending on your use case is good or bad. It kind of depends on what you need and why you're using encryption. So think about the use cases and what is important. One of the things I would caution you, this is actually a meta threat, be very, very careful about accepting any encryption that isn't based on a standard, right? There are a lot of companies out there that are selling encryption products that they will tell you are very secure and very fast. Encryption really is a very, very hard problem. People don't find about holes in encryption until they study the source code and the algorithms in detail. So the chances of having bad encryption, if it's not a public standard, is very, very high. So please don't use anything that's not AES or something equivalently strong, preferably with an initialization vector. So yeah, just stay out of that stuff. Okay, so that's what I've got. If you need help, there's lots of places to reach out for help. Those are the Hadoop and Hive dev lists. If you find security holes, please report them to the security at the different projects. Those are private lists, so those just go to the developers, and you can't join those. That's where you report security holes so that we can work on them and get them fixed. Thank you very much. Any questions? Yes. So there are a lot sorry, the question is how would I guide enterprises when they already have security systems that they need to integrate with? It kind of depends on what they need to integrate with. For example, a lot of companies have Active Directory. That actually works for Kerberos, so you can integrate with that. If you need to integrate with a single sign-on, a lot of companies have a mandated single sign-on. You can actually add custom filters for all the HTTP servers that let you do the HTTP authentication using those instead of a standard one. And actually, most of the large web companies have those. So eBay, Yahoo, Apple, they all have their own single sign-on for web properties, and they've integrated them into Hadoop, and those work great. Okay? More questions? Yes? So, okay, so the question is, what's the minimum viable? And so yes, absolutely start with the firewall, and if you've only got a small team or a single team, that works great. Actually, you don't need Kerberos at that point, you don't need anything. And actually we ran with Hadoop a long time with exactly that setup. The problem came when we had different groups with different data protection needs, and they needed to be protected from each other, right? If there's a secret project that no one else is supposed to know about, that's hard to do without real authentication. If you've got someone that's got financial data in Hadoop and there are other teams that aren't supposed to see that, that doesn't work well. So while each team has their own Hadoop cluster, yeah, absolutely. Just do a firewall and then call it a day. If you've got multiple groups sharing, sooner or later you're going to get to the point where you actually need Kerberos. And actually that's a very common pattern, is people start with small clusters to do a little bit of work, and then it expands as the data comes in and the other teams come in, start sharing, and then that leads to more and more needs for security. So most people don't start with security, although that would be easier. They start with security turned off and then add it as they go. But yeah, don't start without the firewall. The firewall is a good base level. Not to say that Facebook doesn't run without firewalls. So you can do it, it's just scary. Yes? So the question is, when is ORC column encryption going to be available? I've been working on it, so it'll probably be, well, it depends where you mean available. It'll probably be a couple months before it's done and checked in. So then it'll probably be a couple more months until it's out in the distros. So the question is, can you encrypt, do you have to encrypt data while you're ingesting, or can you modify a table in place? With HDFS, we can't rewrite files except by rewriting them. We can't modify files. So the answer is you're going to have to do it on ingest or go back and take a sweep through and read the file, write the file, and then replace it. Now the key names are going to be stored in the file, so you'll know whether it's encrypted, and so the reader will transparently handle that for you. So you won't need to switch on that piece, but yeah, you're going to have to encrypt it as you're writing, otherwise HDFS can't deal with it. Yes? So I haven't done a lot of experiments with the encryption. A lot of it depends on exactly which piece of it you're talking about. So the stuff that's built into on the wire encryption, for example, is different from the HDFS HDFS encryption zones. So which piece were you asking about, or all of it kind of? Okay, so for the column encryption, there's going to be, it'll list the keys it needs, and so it just has to talk, each task will just have to talk to the server once to get the key. So it'll only be one extra. So it won't cause that much impact other than the cost of doing the encryption or decryption. So I'm expecting. So, okay, let me, the column encryption I don't have finished yet, so I haven't done benchmarks with it, so I'm not sure. We should be able to get it down so that it won't significantly impact the throughput rate. There'll be a little bit extra when you start up because you'll need to talk to the key server, but it shouldn't be excessive. I would expect the performance to be, 5% slower, something like that. Yes?
Does HTTP 2.3 fully support multi-tenancy?
Multi-tenancy is such a wonderful question. So the question is does HTTP 2.3 fully support multi-tenancy? It's made a lot of improvements. For example, there's the RPC queuing, and that actually goes a long way in terms of guaranteeing that if a single client doesn't do a denial of service on your name node. Because we've seen cases where some client goes crazy and starts reading or writing too many files, and they can slow down the name node for everyone. And with the newer versions of Hadoop, you can actually define the back pressure strategy and say, okay, if someone is using the name node too much, start throttling them and slow them down. And so we find that actually does a really good job of increasing the multi-tenant, or increasing the isolation between multiple tenants.
We're running a multi-tenant cluster. Does that change
It. As we discussed previously, if you have a homogeneous cluster with a small team, then you've got a very simple security story. So no, it doesn't change it very much. You need to do a little bit more due diligence to make sure to be careful. In particular, one of the things that I've had clients with issues on is the Hive queries tend to put their query name into the job title. And so a lot of companies find that problematic, but you can actually turn that off, and so that you don't end up with, so you're hurting your usability some, but on the other hand, you're not leaking information. So there are some helpful pieces there. Yes? Not that we've observed. So the question is there a theoretical limit? Now, part of the reason that we aren't hitting the limits is that when someone mentioned it actually in one of the questions, is we use delegation tokens. Oh, it was you, actually. We use delegation tokens so that we don't have to keep going back to the KDC for each node each time it connects. And so typically you're limited by how many nodes your name node can support. So I've seen clusters working in production at 6,000 machines. For most companies, that's enough. Most companies only wish they had 6,000 machines that they could run on it for a single cluster. But anything else? I think we're just about out of time. All right, well, thank you very much.